that we're doing application of PN
Junction diode.
junction diode. Please tell me some applications which you have learned already. Please tell me. Number one, PN junction diode can be used as a
Rectifier.
rectifier. Yes. Number two, PN junction diode can be used as a
Photo.
photodiode. Okay, it's a special diode. Okay. Number three, PN junction diode can be used as a
LED.
LED. Today we are going to learn PN junction diode can be also used as a diode, which we can call it what diode?
Zener diode.
Zener diode or Zener diode. Okay, and Zener diode has a very specific purpose. Okay, Zener diode is going to do this. Look here. The purpose of Zener diode is to act like a voltage regulator. I'll send you the notes. Okay, how much to study I'll tell you. Okay, voltage regulator. I'll tell you what is the meaning of voltage regulator. See, okay, this is your TV. Okay, no, you know TV, of course. Then if this is your TV and you connected two plugs, right, socket, no, you do that, of course. Okay, you are going to connect it 2 points. Okay, and that's how the current enters your TV. Okay, so yeah, this is what is going to happen. Imagine, okay, your TV needs let's say 220, not 20, let's say, okay, 60 volts. Okay, just an example. Okay, new TVs, new LED TVs, they need very less. Okay, old TVs, they need very much high voltage. Okay, let's say 60 volts for the time being. Can you say what is 60 volts, guys? So your TV needs how much? 60 volts, right? Yes or no? If your TV does not get 60 volts of potential difference, just an example, okay, your TV will not work. Okay, so look at this. Okay, but 60 volts is sufficient, suppose. Okay, but suppose I tell you, sometimes did you notice the voltage, what happens to our voltage, the electricity that we get? Every time, do you think the constant voltage reaches, or sometimes the voltage spikes and sometimes it falls down? What do you think happens? Sometimes you get what kind of voltage? Reaching a highs, reaching a house. Sometimes it becomes very high, and sometimes it becomes what?
Low voltage.
Low voltage, no? Imagine this high voltage reaching your TV. This is the socket, okay? Imagine a very high voltage peaks, okay, and reaches your TV. What will happen? Your TV will become
Blast.
it will become a bomb, no? Something will blast inside. Okay, let's not worry about that also. But do you understand, guys, what I'm trying to say? Yes or no?
Yes, sir.
Okay,
Yes,
so
sir.
what do you want to do? You want any voltage to enter your TV, or you want to regulate that voltage? We want to regulate the voltage. I'll tell you the meaning of regulation. Okay, regulation means I'll give an idea. Okay, you have a regulator in gas also, no?
Yes, sir.
Okay, what do you do with regulator in a gas stove? You control, no? You control what? The amount of
Fire.
the amount of fire or amount of gas you control?
Amount of gas.
Amount of gas coming from the cylinder to the stove, no? Okay, so you control that with a regulator, right? Same thing with voltage regulator. What can voltage regulator do? Voltage regulator can tell me.
Regulate the current.
Can regulate the current or voltage. Voltage regulator will control the voltage reaching your device. Can you understand? Your TV needs how many voltage? 60 voltage. Then this voltage regulator has to make sure that how much is going to your TV? 60 volts. But suppose it is 400 volts, just an example, during peak. Okay, very high voltage is coming, but your TV needs only how much? 60 volts. So there has to be a device. Look here, there has to be a what? Device that will take this 400 volts, and how much it will make reach to the TV, guys. Out of 400, it will regulate and make how much? 60 volts to reach the TV. Can you understand? Then I'm going to say that it's a regulator, no? And who can do it? A zener diode can do it. Okay, so that is what I'm trying to say. Okay, so see, I'll draw the diagram. Okay, let me write the questions first. First question is, what is a zener diode? Okay, don't worry, you got the idea, I think. What is a zener diode? Okay, that's the first question. Okay, then number 2, why your zener diode is a special diode? Okay, why it is special? Okay, then how can breakdown voltage be changed? Okay, breakdown voltage be changed. Don't worry, I'll answer all of them. As I draw the diagram, I think things will become more clear. Okay, and then there is little bit of theory you have to study plus circuit diagram. Okay, then theory plus circuit diagram, and of course you are going to have one formula there. Okay, so I'm just going to talk about that. Okay, now let me tell you what is a zener diode. See, I'm just going to talk in terms of points. Okay, then I'll stop. Okay, I'm not interested in this topic much. Okay, to teach here. See, so what is a zener diode? The first answer is this. Okay, a zener diode is a special, okay, let me not say special right now, let's say it's a very properly doped, properly, or let's say heavily doped p-n junction diode. Okay, do you understand this one? First of all, what does it mean, guys? What is the meaning of heavily doped? Who can tell me? What is the meaning
Impurities.
of we are adding
Impurities are
impurities. Impurities are added. Lightly doped means impurities are added, or very few impurities are added. Lightly doped means few impurities are added, few impurities. Okay, like your pentavalent and trivalent. Okay, heavily doped means what? A lot of pentavalent and trivalent impurities are added. Lot of phosphorus will be added, lot of arsenic will be added, gallium will be added. Okay, aluminum will be added. Okay, so zener diode, you always remember, it is always what, guys? It is heavily doped. Okay, and why it is special, I'll tell you. Okay, it is special because zener diode has a very sharp breakdown voltage. I'll explain to you this one. Okay, so please memorize right now only. Please tell me, guys, why zener diode is special? Tell me.
It has sharp voltage, breakdown voltage.
Sharp voltage or sharp breakdown voltage? Sharp breakdown voltage. Okay, it is made, look at this, it is made to work. Okay, it is made to work in which bias? You know, it is made to work in which bias? Reverse biasing in breakdown region. Okay, in breakdown region, don't worry, I'll explain to you. And it will work and without getting spoiled, so this is how you are going to make sure that, yeah, it is a zener diode. These are the properties. Okay, so give me some time, I'll explain all of this. Okay, so look at the diagram. Okay, first of all, let me show you the symbol also. See, if I draw just like this, what is this, guys? This is just a symbol of what, guys? PN junction. Okay, if I draw a circle and draw light like this, tell me what is this? Is a PN junction, or I have to call it light emitting diode? What is this?
LED.
Light emitting diode. Okay, if a light falls on it, what do I call it?
Photoelectric diode.
Photodiode. Yes, photodiode. Okay, but look at this. If I come and draw this, okay, two lines here, can you see? It looks like Z, no? Those lines, can you see?
Yes, sir.
Now this is a symbol for which diode?
Zener diode.
Yeah, it's a symbol for zener diode. Okay, I think I have copied. Okay, again. Then this is a symbol for zener. Guys, you guys are clear, no, with the symbol, right? Check. All of you.
Yes, sir.
Okay, so symbol is at least clear. Okay, symbol is at least clear. Okay, now check what do I mean by reverse region. No, let's see. If I tell you this is reverse voltage, this is what? Reverse voltage, and what is this? Current or reverse current? Reverse current, right? If you remember, okay, if I keep on increasing the reverse voltage, what happens in a diode? Tell me, guys, please waiting. First of all, tell me what kind of current we are going to get, micro or milli? Micro amperes. Okay, fine, that's one thing, no? Then you tell me, okay, at the beginning, what is the trend, or what is the behavior of current? If I keep on increasing the voltage, does it increase or increase very slowly? Very slowly, and very slowly. But a time will come, right? What will happen after reaching certain voltage? This voltage has a name, I told you. We call it what voltage?
Breakdown voltage.
This is the breakdown voltage in the reverse biasing. Yes, it is called breakdown voltage. We call denoted by VZ. Another name is what voltage? We have a name for it. What is this? Zener voltage. Okay, it is another name is, yeah, zener voltage or breakdown voltage. And what happens when we reach that voltage? Tell me, guys. The bonds in the which region? In the depletion region, right? The bonds will be still intact, or this voltage is so large that it can break the bonds. It can break the bonds. Okay, please remember this. Okay, it will break the bonds, and the bonds will be broken, okay, for not only one of them or two of them, it will be broken for many of them in that depletion layer. If you remember, we have p type we have n type, and this region is called depletion layer. We have n type, p type. These are positively charged holes, negative charge, majority, plus here, minus here. This becomes minus, this becomes plus, right? Okay, but because you are applying reverse voltage, check, okay, this is p type, you have to connect negative. This is n type, you have to connect positive. This is called reverse biasing, if you remember. And this happens, look here, if this reverse voltage that you apply becomes very very high, okay, and it depends on the diode, by the way, see, because you have the option of doping, right? You can add few impurities, you can add lot of impurities, and you can shift also, okay, you can shift. See, right now I'm saying, suppose the zener voltage is exactly 60 volts. That is up to you. You decide it, okay? You are going to decide what will be the zener voltage. Please understand this, okay? I'm repeating again. Who decides how much will be the zener voltage? You are going to decide it. How are you going to decide it? By adding impurities, okay? I'm repeating again. You can change the zener voltage by changing the concentration of impurities. You come and add more and more impurities. Look what will happen. The zener voltage will not be here. The zener voltage will shift. It will become here 30 volts. Can you understand? 30 volts and 60 volts. So which voltage do you want? Look here. If you want the zener voltage to be what, guys? I'm repeating again. Breakdown voltage, you want how many volts? 30 volts. What will you do? Tell me, guys. You'll add impurities, or you'll add more impurities?
More impurities.
Are you clear? Are you clear with this one? Yes or no? Please tell me. waiting, guys. So I'll ask you another question here. How can you lower zener voltage? How can you lower zener voltage? What is the answer?
By adding less impurities.
Wrong. Just ulta used to tell every time, Rishikesh to are. How can you lower zener voltage? By adding more impurities. He's ulta, okay? He's upside down, okay? He's always like this. He's always upside down, okay? He sleeps at day. He wakes up at night, okay? He's like that, no? Ulta, okay? So how can you lower zener voltage? You can lower voltage by what, guys? Adding more impurities, okay? If you want the breakdown to take place at 60 volts, you add less impurities. So let's say right now zener voltage is 60 volts. That means, you know what, if I apply till how many volts? Till what volts, guys? Let's say 59 volts, okay? Please look at this diagram. I think you'll understand. So how much voltage we are applying right now, guys? Tell me. Look at this. How much voltage? Can you see, guys? All of you talk. You talk also. 59. Okay. Suppose you imagine you are applying 59 volts. Now think and tell me. Okay. We have reached the breakdown, or we have not reached the breakdown?
No, sir.
That means till 59 volts the current will rise very very slowly. Okay. Because till 59 volts no breakdown. But the moment I hit how many volts? How much voltage I apply now here? 60 volts. Yes, the moment I apply 60 volts, now all these bonds will like suddenly, okay? It's a very rapid process in zener diode, I'm telling you. That's why it's a special diode, okay? Suddenly all these bonds will be broken like very, very quickly. So if it is broken very, very quickly, what will happen? Tell me. Will I get current, or reverse current will shoot up or become very, very high or not? Increases. But look at the trend. I did not draw it like this, okay? This is wrong. This is for your normal diodes. But are we talking about normal diodes or special diodes? Specially constructed diodes, okay? We are talking about specially constructed diodes, and for this specially constructed diode that is called zener diode, the current is going to shoot up like anything. Look at this. The moment it hits 60 volts, the current is going to go boom, okay? Very fast. Rise very, very fast. Can you understand till here? This is the meaning of sharp breakdown voltage. Can you understand now? So who has sharp breakdown voltage? Tell me. Any diode or only zener diode?
Zener.
It is constructed in such a way to have this effect, okay? Yes or no? All of you waiting, I'm waiting.
Yes, sir.
Okay, Rohan understood. Rishikesh understood. Donna.
Yes, sir.
Okay, Srishti understood. Okay.
Yes,
Yeah.
sir.
Now, yeah, the diode, no, you know what?
Yes, sir.
Yeah, the diode, no, is made to work in the reverse biasing. That what is we know, and it is going to work in which region? In breakdown region. Just imagine it's going to it's made to work in breakdown region, and it will not get spoiled. I'll tell you what does it mean. See, that means If it was a normal diode and you allow this current to pass, I have already told you before what will happen in this region. What is this called? Breakdown region, right? What is the property of this region? Current is what? High or very, very high? Current is very, very high. What kind of resistance we have here, guys, right now? Resistance is high or
High
low?
resistance.
Very high resistance. How much heat will be produced, guys? High or very, very high amount of heat will be
Very,
produced.
very high.
So you tell me, if it is a normal diode, will it be spoiled or not spoiled?
It will be spoiled.
It will be spoiled. So another way zener diode is special is why? Because these people are going to make it such that you can allow this current, okay, you can allow this current to pass, reverse, very high reverse current, let it pass, let it become hot also, but the device will not get spoiled. Can you understand why this zener diode is special, guys? Please tell me. Because a very high reverse current or breakdown current can pass from what? From the zener diode. It is special because of that, and it will also not get spoiled. Okay, so that is what I've written here. Okay, so I will send you the note, you can read again. Okay, but you are still confused. Okay, so how can breakdown voltage be changed? I've already told you breakdown voltage can be changed by what? Changing what? Concentration of impurities. I've answered you that. Then how it is like a voltage regulator, then how it is useful as a voltage regulator, right? This is nobody has understood till now, because obviously I have not discussed that, but it is all dependent on this diagram. Okay, so this diagram is very, very important. So if they ask you, draw the characteristics of a zener diode. See, if it is a normal diode, no, please remember, if it's a normal diode, draw like this, and maybe like that. Can you understand? If it is a normal diode. But if it's a zener diode, you really have to draw this like almost like a parallel line here. Okay, so be very, very clear with that. Okay, now I'm going to talk about how it is going to act like a voltage regulator. Okay, so I am going to bring draw one circuit diagram. Please check. Okay, see, suppose I have a voltage, I call it VIN. Okay, this is input voltage. Let's call it plus, let's call this as minus for our input voltage, and this is what kind of voltage? You know, it is fluctuating. Okay, fluctuating DC voltage. I'll help you out. What does it mean? You'll understand the moment I tell you what is this. First of all, I think you understand the meaning of this, right? What is this? It means what? Constant or changing? Oops. It means changing. Changing. Where is it? Yeah, okay. Fluctuating means changing. And your TV does not like change of voltage. Very high voltage, TV doesn't like. Okay, very low voltage, TV does not like. But you have to give input to the TV, right? So it's going to come from here. It is coming from the source, you can think. Okay, it is coming from some source. Okay, now your TV is here. Look at this. This is your TV. Okay, your TV needs to be connected to this resistance. From here it will be taking out as the output. Okay, so these are the points. Your TV, I'm just drawing it. Okay, exam time, please don't draw TV. Okay, your teacher will start laughing. Okay, right now if you just draw TV, but try to understand what does your TV wants from here, guys. Let's say this is RL, the load resistance. What does your TV wants? Please tell me. Let's be clear with this. It needs voltage or not?
Uniform voltage.
Uniform voltage. Okay, how much voltage it needs?
60.
60. Okay, just an example. Okay, don't write exam. Please remember this. Exam time, don't come and write 60. Okay, you guys are remembering 60. Please do not write this. It can be any voltage, but I am giving an example. How much your TV needs, guys? 60 volts for best operational voltage. Are you clear with this? Yes or no? Waiting.
Yes, sir.
Okay.
Yes, sir.
And what can happen to this voltage? Please tell me. What can happen to this voltage? Can this voltage be 40 volts? Yes. Can this voltage be 50 volts? Yes. Can this voltage be 70 volts? Yes, because it's fluctuating, right? It can change. Can it be 200 volts? Yes. Can it be 300 volts? Yes. Okay, it is fluctuating right now. Okay, so I'm just telling you it can change. But what do you want here? Between these 2 points, you want different voltage or constant voltage? You want
Constant
constant voltage. Is it okay till now? Look at the diagram. This is the input, and the output that you want is constant. That's it. Is it okay or not? Tell me, guys.
Yes, sir.
Okay, so how to achieve this? Okay, check. Okay, how to achieve this? I told you, you will need. Who will help us? Who will come and help us? What do we need here? We need a
Zener diode.
I have not drawn zener diode till now, but I'm going to draw now. Check. Okay, I'm going to connect the zener diode somewhere here like this. See, I think you can understand the symbol, right? This is the symbol of zener diode. Okay, so this is how you're going to keep your zener diode. And you know what? you are going to connect your output directly to your zener diode. Did I make sense? Check. This is how you should connect. This question comes, okay? Are you clear with this? Check, guys. How do you connect your zener diode? How do you connect your zener diode?
Parallelly.
Parallel,
Yes.
yes. Parallel to what? Parallel to what?
Load resistance.
Load resistance. Very good. And from the load resistance, what do you get? You get
Output.
output. Okay, you need 2 points, no, to for the TV to work, and that load resistance will give you those 2 points. Okay, so please remember, this is how you're going to draw. Okay, your zener diode. This is how you should connect. Okay, now check. Please check nicely. I told you just a while ago, your zener diode is always connected in how? Forward or reverse biased? Which configuration?
Biased.
Reverse bias. Okay, so I'm going to show you that right now. Check. Okay, check. This is the positive of the input voltage. I'm going to join with the N type. Can you see? The positive is connected to what? N or P, guys? What is this? This is N and this is P, no? So positive is connected to what, guys? Please tell me. Waiting.
N types.
N type. Okay, so and the negative is connected to what? Is connected to P type. So tell me, this zener diode right now. Okay, this is a zener diode. Is forward or reverse biased?
Reverse.
Otherwise it is not going to behave special. Okay, it's only special in that breakdown region. I told you, right? Because it will work and without getting spoiled. Okay, so yeah, it is very nice that it is reverse bias right now, but we need one more thing. Please remember this. Okay, this also is very important. Look here, between the zener diode and the source, I'm also going to keep one more resistance. Very important. Again, you really need this here. Okay, this one I call it, sorry, not V, this one is RS. Okay, I call it resistance in series. Okay, or just let's call it R also, but right now I'm just calling it R right now. Okay, we really need this resistance. It has to be connected. Without this, your zener diode again is going to be useless. Okay, it cannot help you out. Okay, I'm going to tell you the theory now. Okay, please check whether it makes sense or not. Okay, I'm repeating again. Okay, tell me whether it makes sense or not. Okay, check. See, let me forget about all of them right now. I'm not worried about them. Let's say a voltage of 200 is coming right now. Okay, right now the voltage is how much, guys? Input voltage is how much? Please tell me. Waiting. This is the main part. I'm done with this. I'll not explain you detail. Just memorize. Okay, other things. Waiting, guys. Waiting. Tell me the voltage how much? 200. Okay. Okay, now check. This 200 will go where? I'll show you. Okay, see, the diagram actually looks like this. This is R. This is your VZ. Okay, this is R. This is your, not VZ, sorry, this is your zener diode that I have taken. Look at this. This is your zener diode. And by the way, you have to also understand one thing. How much your TV needs? How much your TV needs, guys? Waiting. 60 volts. Look at the breakdown voltage. What is the breakdown voltage I have made for this zener diode? 60. And you will agree with me. If your TV needs 30, okay, I'm repeating again. If your TV needs 30, will I use the same zener diode or a different zener diode? Different. Use a different zener diode which will have breakdown at what voltage?
30.
At 30 voltage. Can you understand, all of you, what I said?
Yes, sir.
If your TV
Yes,
needs,
sir.
if your TV needs 30 volts, use this one. If your TV needs 60 volts, use this one. Okay, I think you understood. Okay, what I'm trying to say. Okay, but don't worry, we are fine till now. Okay, your TV needs 60, so this is the diagram right now. Okay, our main diagram now actually looks like this. Okay, I'm just drawing it again. This is the input, right? From the input, it goes to what, guys? I told you it goes to a resistor. Check. From the input, it goes to what? A resistor. From the resistor, it goes to PN junction diode. From the resistor, it goes to PN junction diode. This is plus, this is minus, this is N type, this is P type, and then it goes back again. Okay, but where is your TV? I'll show you. See, your TV is connected between what and what? Across the zener diode or not? Check. This is our diagram. Check. Somebody pointed out, no? Your zener diode and your TV are parallel or not? Check the diagram. Is same or not? Waiting.
Yes, sir.
Check. These are same. Okay. There is an input voltage. You can see this is input voltage. Oops. So here also we have an input voltage which is 200 volts. I'll just give you an example. Okay, right now. Then there's a resistance here. After the resistance, there is a, sorry, not that, zener diode. We have zener diode here. You can check. and this is how it looks like. Okay, so now check. Now why am I talking about all these things, right? So now see, just now I told you how much is the voltage, guys. 200 volts, right? Check now. What will happen to the 200 volts, guys? Please look at the diagram and tell me. Will it just be at the source or it will be distributed? Will it be at the source or it will be distributed? Some part of 200 volts will go here. Let's call it VR. And some part of that 200 volts will go there. Can you understand? Let's call it, I'll just call it V, but I'll tell you what is that called. Okay. Can you understand, guys, what is going to happen to 200 volts? Some part of the voltage will go here and some part of the voltage will go there. Can you understand this, all of you? Check, check, check.
Yes, sir.
Yes, sir.
Okay. Now try to understand, okay? If this zener diode gets 70 volts, just an example, it will not get, don't worry, okay? But suppose if it gets 70 volts, tell me what will happen. Let's go back to our diagram. This is like your 70 volts. Let me show you where 70 volts, okay? What is this? 70 volts, right? If your zener diode gets 70 volts, what does it mean for the zener diode? Can you think? What does it indicate for zener diode? Are we in breakdown or we have cross breakdown?
Cross breakdown.
We have crossed breakdown. Okay, your zener diode is going to do this. Look here, your zener diode is going to say that at what volts? At what volts, guys? 60 volts. The zener diode has given all the currents it can give. Can you understand this graph? I'm repeating again. Please tell me what happens with zener diode, our zener diode. At what voltage it gives all the current it can give?
60.
At 60. Can you understand this? I'm repeating again. The zener diode gives all the current at what voltage?
60.
Its breakdown voltage, and that is 60 right now. So if somebody comes and tells to zener diode, okay, no, we will apply 70 volts. What will zener diode say? Zener diode will say 70 volts has no meaning for zener diode. Can you understand? Your zener diode does not understand what volts. Do you understand this, guys? Did I make sense? Because what is the zener diode going to say? I have already done, okay, the zener diode is speaking, okay. At 60 volts, zener diode has given all the current it can give, all the current. And you can see the graph shoots up like that. I showed you, right? Breakdown is taking place. So when we apply 70 volts, right, what will zener diode do? Tell me, guys. He says, out of the 70, he can only take how many volts, guys? Check. He can only take 60, and he does not understand. The zener diode has no graph at there. See, 70 volts does not give any current to the what? Any additional current to zener diode, okay? So it happens only till 60. So nothing else happens after that, okay? So look at the idea here. Now what is the important point? Look here, see. If 200 volts comes in the input, please tell me, what is the zener diode going to say? Waiting. Zener diode will take how much? Out of the 200? All of you?
60.
It will take 60 volts out of that. And what is the 60 volts? It is the breakdown voltage, right? The remaining will appear here. Can you understand? The remaining will appear there, and the remaining is how much? 140 volts. Can you understand what is happening? The voltage is getting distributed, but the distribution will take place in such a way that the zener diode, right, is going to allow the current to pass. The current will be reverse current now, like this. This is your reverse current. I can just call it IZ. Current passing through the zener diode. I can show you the direction of current also. See, let's start from positive. Current goes here, current goes here, current goes here. Current is passing from the resistance. It's a normal standard resistance, so it will not get spoiled. Current reaches here. The amount of current, okay, let me just call it I right now. This is the current I. The current which goes to the output, let's call it IL. The current in the load resistance, and this is the current in the zener diode. I think you can understand the current splits, right? Okay. Now, do you agree with me that something very nice is happening? Check. Is this going to be a large current or small current? I've written small already. But guys, let me tell you why it's a small current. Do you agree with me that what kind of current is this passing through the zener diode? Is it large or small? Large. Because look at zener diode. Zener diode is in just any ordinary voltage, or it is in zener voltage right now? It is in zener voltage, the breakdown voltage. That means the current through the zener voltage will be very, very high. So most of the current will pass from here. And do you understand that this current will not reach your TV? This will be a smaller current, right? Will a large current reach or small current reach your TV? What do you think? That's what I'm asking you. Check now.
More current.
Okay, I'm repeating again, okay? What about this current and this current, right? This current is the current passing through zener diode. Please, okay, I'm asking you again. Please tell me, is it a small current or very, very large current?
Very, very large.
Waiting. All of you, did you understand why it's a very large current?
Large.
All of you, did you understand why it's a very, very large current?
No, sir.
No. It is
Sir,
a
can you
very...
repeat?
yes. It's a very, very large current. Why? Because, tell me, look at the zener diode and tell me, right now it is in just any ordinary voltage, or right now he is getting the zener voltage? He's getting extra voltage or not? Or the breakdown voltage or not? Check. And why it is happening, I'll tell you again, okay? Look at this voltage. What do you think? It's a voltage or very high voltage? 200 volts.
Very high.
Very high.
Very high. So where does this voltage get? It gets distributed, right? It gets distributed when and where and where? Tell me. Where does it go? It goes here. Some part will goes here, okay? And some part goes here, across the what? Zener diode, okay? Let me give an example, okay? If 100 volts goes here, right? How much volts will go here? Out of that 200?
100.
100, right? But I told you earlier also, does this 100 volts has any meaning for the zener diode, or it does not take that 100 volts?
It does not take.
It cannot take 100 volts. Look at the graph for zener diode. Your zener diode does everything at what volt?
60.
At 60 volts in this example, okay? 100 volts has no meaning for your zener diode because it gives all the current at what volts? 60
Give me
volts.
this current.
60.
Okay. That means there's no point, okay? Or let's say there's no need to talk about, or let's say your zener diode cannot take more than how much voltage, guys? That's the whole point. Your zener diode cannot take more than what volt right now?
Volt.
60 volts. Can you understand now at least? So look here, can this happen or this will not happen?
This will not happen.
This will not happen. So maximum he can take is how much?
60.
60 volts. All of you understood now? If he takes 60 volts, automatically this resistance has to take how many volts?
140.
Now did you understand, guys? All of you, check.
Yes, sir.
Sir.
Okay, so now your zener diode will take how many volts? He will say he will take 60 volts. And do you agree that now if he takes 60 volts, what kind of current will pass through the zener diode? It will be reverse current. Yes, it will be reverse current, but it will be high or very, very high? Yes, it will be high or very, very high
Very,
current?
very high.
Very, very high. So very high reverse current will pass through it. But do you understand that this current, right? Will it pass through your output or it will not go to your output? This high current. Look at the direction of this current. This will just go from here to here to here to here, if you can see. Okay. And obviously some current will pass from here. But that will be, what do you think? It will be high current or low current?
Low.
Low current, because already very high current will pass from him. It will pass from zener diode. Can you understand your TV is safe? If a very high current passes from your TV is gone, no? Yes or no?
Yes, sir.
Okay. Guys, I think I'll not explain much more than this, okay? If you have understood, it's fine. If you have not understood much also, it's fine. Actually, I'll say this topic, okay? But look at the final thing. Look at this. So please tell me what is the voltage your zener diode is getting right now? How much is getting?
60.
60 volts. Okay, that's the voltage between these 2 points. Okay, between this point and this point, 60 volts. Okay, now look at your load resistance. Do you agree your load resistance and the zener diode are connected in series or parallel?
Parallel.
So,
Parallel.
Parallel. That means if your zener diode gets 60 volts, your load resistance also should get how many volts?
60 volts.
Will your load resistance get more than 60?
No, sir.
No. Can you understand? If your zener will get 60 volts, your zener cannot take more than 60 volts. Your load resistance also cannot take more than 60 volts because it's connected in parallel. In parallel, you have same voltage. Okay. Therefore, you tell me now. Your TV is also connected. Okay, like that. See. So you tell me now. How much your TV will get now? 60 volts. Are you clear? This is your TV is safe now. Okay. But all of you, did you understand? I'm done actually with zener diode.
Sir, but why low current?
Low current, okay, I'll tell you. See, okay, Rishikesh, look at this. This is path A and this is path B, okay? You connect your TV here, okay?
Yes, sir.
Okay? Okay, the current is coming from here. The current is coming from here, it gets divided, no, check? It gets divided here, right?
Yes, sir.
Okay, if it is 10 amperes, no? Some current will pass from here, some current will pass from there. Can you understand?
Yes, sir.
Okay, now you tell me, is your zener diode is a special diode, right? Okay, and in the breakdown region, what happens to this in breakdown region? Tell me. In breakdown region, what kind of current do I get from this diode? Do I get current or very, very high current?
Very, very high.
Very, very high current. That means whatever current is coming, right? Most of the current will pass from here or not?
Yes, sir.
So how much will go there now? Out of 10, 9 is going there. So how much will go there?
1 ampere.
But do you understand now? Why low current? This one.
Sir, but 1 ampere is enough to on the TV.
It's just an example. This is just an example. 10 amperes, I just gave an example.
No, sir, but low current is.
When I say low current, see, I'm comparing obviously, right? Okay, when I say low current means what? I'm comparing the current through this path and the current through this path. So you decide,
Yes, sir.
okay, you decide, Rishikesh, which path do you think will get more current? The
Sir,
current through zener diode or the current through TV?
zener diode.
From zener diode, that means your TV is safe, right? Even in the case of very high voltage, look at this, very high voltage. What do you expect this current to be? Tell me, Rishikesh. This current will be high or
Very
very,
high.
very high? Very, very
Very,
high.
very high.
But look at your zener diode. Your zener diode says, no problem, I am a very special diode. Even if I work in the breakdown region, I can allow a very large current. This is nothing. 9 amperes is nothing for him. Maybe 10 amperes also it can what? Pass. Can you understand? And it will save your TV. Do you understand now? See,
Yes,
exact
sir.
numbers I'm not writing, okay? Exact numbers, of course, we cannot write, okay? Guys, I'm done for today, okay? But, oh, no, not for today. I'll quickly go to your question papers very quickly. I'll just discuss. I'm going to stop projecting from here, okay? Just give me 1 second. Stop sharing. I'll share from here now, okay? Share, what is that? Share your entire screen. Screen 2, I think, okay? Screen 1 I will share screen 1. Okay, so can you see my screen already?
No, sir.
Now you can see. Now you can
No,
see, no?
sir. Oh,
Now you can see. You check, you have to change my name, okay? Go to the other name. There are 2 Rohits there, no? RC is there, I think. I don't know which one is there. You check. Can you see I'm broadcasting?
yes, sir.
Okay, physics main folder kaha gaya? Class 12. Okay. Yes, I am going to discuss questions from your semiconductors. Okay, one by one. Let's start from 2010. Oops. So once we do this, it's done. Okay, look at your first question. Okay, let me zoom in. Can you see this, guys? All of you. Okay, read the question. Very easy. Waiting. I don't read the answer. Okay. What is the question, guys? Check. In forward biasing, what happens to the width of the potential barrier in forward biasing? The width is
Decreases.
big or small? Small. So it
Small.
decreases. All of you clear with this one? Just check. Half mark question. Easy now, I think.
Yes, sir.
Decrease.
This one is from different chapter. This one is from different chapter. 5, 6 is from different chapter. Let me find. There should be one more question, no? Kaha gaya? From semiconductors, there should be one more. 8, 9. Oh, transistor it came. So it is no longer there in the syllabus. So you're fine. Let me search. Okay, this was also from semiconductor earlier. Don't study this one. Okay, if you see this kind of question, don't do. Okay, this one. Removed. All these topics are removed. Where else we have question, Ray? Let me find out.
Sir, gates are not there, right?
No, gates are not there. Removed. Okay. This topic also, don't study. This is also removed. Where is it? Oh, this one also. See, it was there earlier. Now they have removed. Otherwise, semiconductor was very difficult. Later on, no, it becomes very difficult actually. Semiconductors because of transistors and all. But they have removed. You are very, very lucky. Okay. So where is the question for semiconductor? Done. At least one more question should be there too. This one. See. Look at the question. What is this question, guys? Check. Read. Explain with circuit diagram how PN junction diode can be used as what? Half wave Rectifier, okay. Remember I told you, right? There's a transformer, there's a primary coil, there's a secondary coil, yes or no?
Yes,
In
sir.
half-wave rectifier, how many diodes we use? One or two diodes?
One.
One.
One. Look at this, 3 marks. 1 mark for this circuit diagram and 2 marks for explanation. Okay. So if you want the photo of this, I'll do better this. Okay. I've not sent you half-wave rectifier notes, na?
Yes,
No,
sir.
sir.
Okay. I can send you exactly this. Okay. Let me take the screenshot right now on your what? Where's the print screen? Print screen. Photo. No photo. What is that? Photo. What do you call screen capture? That also I don't know. How do you capture screen in Windows? Anybody knows? Print screen. It's not working. No, it's not working. Okay, I'll send you. Okay, this one. But this is one of the questions. See, very easy one. Okay, whatever we have done. Okay, I'm telling you, whatever we have done, just study that much. I'm telling you. Okay, but study very nicely. Exam time, don't make any mistake. Okay, so this is 2010. Let me go to 2011. So see, okay, 2011. Let me find out where is the question for semiconductors. No, not here. Okay, half mark also they give you. Oh, this one, look here, number 7 question. Please read the question. N-type semiconductor, tell me, is it negatively charged, positively charged, or neutral?
Negatively.
Okay, N-type is called negative type semiconductor. I'm repeating again. Okay, N-type is called negative type semiconductor, but it is not negatively charged. This is a wrong idea. Okay, because you tell me, let me draw here. See, look at this. Okay, look at this. Your N-type, N-type semiconductor, okay, it has lots of what charges, guys? What is this? Lots of
Negative charge.
negative charges, and they are also what? Positively charged holes.
Holes.
You tell me these negatively charged particles, okay, the electrons, they are what? They are electrons, or they are free electrons?
Free electrons.
They're free electrons. Now think, okay, do you think these electrons, okay, do you think these electrons I don't know, I cannot touch it now. Do you think they are really leaving the semiconductor, or they are still inside the semiconductor?
Still inside.
All of you. They are free, but they move inside the semiconductor. Okay, do they leave the semiconductor, or they do not leave the semiconductor? They do not leave the semiconductor. Okay, what does it mean? How does it become charged? When electrons are gained from outside, then it becomes negatively charged. If electrons are lost, if electrons are what, guys? Lost, then you become what charged? Okay, but this semiconductor, you know what? It has many negative free charges, but it does not have a whole negative charge. Can you understand? The semiconductor does not have any negative charge because it does not lose any what? Electrons. Can you understand? The free electrons are just inside. N-type means there are lots of free electrons inside the semiconductor, and they are majority charge carriers. They do not leave the semiconductor. Can you understand that the semiconductor is neutral? Yes or no?
Yes, sir.
So it is electrically
Yes.
what? Electrically
Neutral.
neutral. Okay, doesn't leave. Okay, so that was a very, again, okay, easy question. I have written this in the notes also. Okay, Rishikesh did not study the notes properly.
Sir.
Hmm.
Sir, negative charge is dominating now.
Dominating, what is the meaning of dominating for you here? Yeah? What is the meaning of dominating? Rishikesh, tell me.
They are more in numbers.
More
Negative.
in numbers, yes. We are more in numbers, yes.
It should be
Compared to
negative.
what? Compared to what? Compared to what?
Compared to positive.
But look at this. You did not. Okay, let's take germanium. What is this?
Germanium.
Tell me, okay? Or silicon also. Silicon has how many protons?
4.
14. 14. How many protons?
14.
Okay, silicon has how many electrons?
14.
14, huh? So you tell me now, silicon is neutral or positive, or which one?
Neutral.
Neutral. Do you understand? If silicon really loses one electron out of its system, then silicon will become what charge? Positively charged, no?
Oh, yes, sir. Yes,
Okay,
sir.
but do you realize silicon loses the electron or does not lose entirely outside? Does it throw the electron entirely outside, or still it remains inside the silicon crystal?
Yes, sir. So it
Ah, so
remains inside the silicon. Yes,
yes.
sir.
So now you understand. That's why it is neutral. Can you understand?
Yes, sir. Yes.
Okay. So I'm done talking about that. Okay, it's just that the number of free electrons which are negatively charged, they are more. The semiconductor doesn't become negatively charged. Okay. Then okay, let me quickly find out what. Okay, look at this also. What is a light emitting diode? Very easy one. Say, it's a special diode or not, guys? Light emitting diode made of what?
Yes,
Gallium and
sir.
arsenide. Also phosphorus. Also, actually, I should add phosphorus also. Okay. So don't read from here. Don't read from textbook. This one. Okay. Operated in what biasing it is operated, guys? Light emitting diode. Forward biasing. I hope you're still there, no, guys? Hello, can you hear me?
Yes, sir.
All of you?
Yes, sir.
Listening? Yes. I'm just discussing what kind of
Yes,
questions.
sir.
Okay, so look at this. Light emitting diode, whatever it is, just study for 1-2 marks like that. See, very easy question. Okay, then let's check what else they're asking. See, your question paper physics now is very simple. Okay, I'm telling you, you can score letter marks very easily, provided at least you know what to study. Look at this. Look at this question. Explain the term what? Depletion layer and what? Potential barrier. Only
Yeah,
for
yeah.
only for 2 marks I think they have asked here. Okay, or if you just want to draw the diagram also, you can draw the diagram. See, like that, you draw the n type, you draw the p type, no, n type, p type, you draw the everything that is there in the notes. Finish, you get 3 marks. Look at this. Okay, so please study like that. See, you have seen all these topics. Okay, then what else we have? Let me quickly find out from semiconductors. See, these questions will be repeated. I'm telling you, semiconductors, they don't have any new question. Look at this, 32 again. What is this now? What is this? Half wave or full wave rectifier?
Full wave.
There are two diodes, diode 1 and diode 2. So full wave rectifier. No, see, easy again. Okay, just do exactly from the notes. Whatever I'm giving you, I'm telling you. Okay. Okay, so I'm experienced. Okay, with all these things. Huh? I'm telling you. So that's why I study only this. And if you need all these solutions, I'll just send you. Okay, if you need. Okay, I'm done. See, this one is question 2011. I will show you 2012 very quickly. Okay, check. So just be with me another five minutes. Let's really finish all these things. Okay, check. Color codes, no, not this one, check. Semiconductors, no, not there. Okay, then this one is not, this one is not. Semiconductors here. This one, see again, look at the question again. I think you can easily identify what question they ask you again. See, only what diagram?
Half wave.
Circuit diagram, half
Okay.
wave rectifier. They're just repeating. See, because they don't have any question. Okay, but do you realize what is this question now? They see what is this? Today we did this one. Remember?
Zener diode.
Zener diode. Check.
Zener
Okay,
diode.
they're asking you the explanation, okay, of zener diode. So please, I will send you this. Study exactly this one. Transistor, don't study, it is not there in the syllabus, but zener diode is there. So see, 2 marks. I told you, no, 2 marks it can come. Okay, transistor don't study. Okay, so not there. So please study zener diode, whatever I told you. Okay, you can write so many things about zener diode. It's a reverse bias. It has very sharp breakdown voltage. Okay, and it can operate without getting spoiled, and so many things you can write. I'll send you the exact note on zener diode. Just study it for 2 marks at least. Study the circuit diagram. Okay, then this one is not there. So I'm just showing you what kind of questions they're asking. Okay, so just be here for another 2-3 minutes, that I'm done. This is not there, this is not there, no. This lens maker's formula, you can see. Okay, this is transistor. Yes, this is transistor, not there in the syllabus. Yes, tell me.
Sir, approximately how many marks from this chapter it comes?
Before they used to come for 8 marks. Okay, now I think it will be reduced, right? I don't know, 6 marks, 7 marks, 5 marks, like that. Okay,
sir.
but it might be more also, huh? It might be 8. I think 8 also, because they've removed one whole chapter. Do you know not? Before, no, there used to come communications, and that was very nice to score marks, right? But removed. Okay, so they might just increase also. I cannot say exactly, huh? you have, do you have 2021 question paper with you? This
Yes,
year's,
sir.
last year's, huh? Anybody has?
Yes, sir. Yes, sir.
Anybody has, please send to. Okay.
Okay, sir.
1 second. Okay. Okay, see. Okay, so check now. Okay, then yeah, transistor is not there anymore. This was a question for transistor. N type, or this already same question keeps say. N type semiconductor is what? Negatively charged, positively charged, or this one? Oh, I've already discussed this one. I opened same question paper 2012. Oh yeah, this one. See, this one is transistor. No need. I think I opened this one already or what?
Yes, sir.
I've opened this one already. 13. Let's check. Okay. 13. Here I can't see in half mark questions. Here also I can't see semiconductors. No, I can't see. Oh, look at this photodiode. See, what is a photodiode? So easy question. Okay, like babies. Okay, they are treating you like babies and you are giving a question. See, what is a photodiode? I'll not talk about that. Study photodiode. Then here transistor, very difficult, but not asking anymore. So no, not in the syllabus. Then not here also. Not here also. Not here also. Oh, look at this. Oh, this one you study nicely. See, what is a semiconductor? Very easy question. Discuss the formation of depletion layer and potential barrier. Please remind me. I have to send you this. Okay, let me click the photo right now only. Okay, this one you study. Look, this whole question is a very big question. 3 marks. Okay, but you have to write this and this. Oh, 4, 5 marks. Okay, this one. I think one more. Oh yeah, this one. This whole page you have to study. With along with the graphs. These graphs, remember, right? Reverse current. What is this called? Graphs called, guys? Tell me. They have a name, no? What are these called? Yes.
Reverse voltage and forward.
That reverse voltage and forward voltage. No, they are called
Forward
reverse.
biasing and reverse biasing.
No. They are called forward characteristics and reverse characteristics. Okay, but there is no circuit diagram they have asked here, so it's fine. I don't think so they'll ask. Okay, but you really need to study this one. Okay, you really try to read this. Okay, it's very important. I'm sending you right now only. See, okay, later we don't have time for revision and all. Okay, so you study. Okay, what I'm telling you. Then let's check what else we have from here. I don't think so anymore. Done. Okay, one more question paper, then I'll stop. Okay, 2014. Let me quickly show you. See, not this one. We can do like this for every chapter. What kind of questions they're asking, no? As some of you wanted to know, what kind of questions they're asking. Okay, I think semiconductor, guys, are you clear what you have to study? Yes or no? Waiting.
Yes, sir.
Transistor.
Yes, sir.
If I don't study, then
Yes, sir.
okay, at least you know what to study. This one again. See, these people, they don't have much question again, but read this question now. See, read. What is a word? Intrinsic semiconductor. You know what is an intrinsic semiconductor? Yes or no? Extremely pure
Yes, sir.
semiconductor without any what?
Doping.
Without any
Impurities.
doping, without any impurities is called intrinsic. Okay, easy. Name the type of extrinsic semiconductor that we get after doping with arsenic. This is question is not full here. Okay. If I add arsenic, what kind of semiconductor we get? Tell me, guys. Trivalent or pentavalent? Arsenic is
Trivalent.
pentavalent. Arsenic is Rishikesh. What valent?
Pentavalent.
Pentavalent. So what kind of semiconductor I'll get? N type or P type? Guys, tell me. Don't look here.
P.
Third, Rishikesh is
N
always starts with wrong. Pentavalent, Rishikesh.
Yes, sir. Negative.
N type मिलेगा ना P type?
N type.
N type. And germanium is doped with gallium. What do I get?
P type.
P type. Because gallium is what, guys? Tell me. Trivalent or pentavalent?
Trivalent.
Trivalent. Okay, Rishikesh. Why you make every time? The first answer is always wrong. Confused? Why are you always? Whole year he is confused. Like this, though, you will score goal in your own goal only, no? You score if you when you go to play football. No. You do that also sometimes, no? अपना ही goal में goal कर देता है. Okay, Rishikesh, after getting confused, he's a football player. Okay, by the way. Rishikesh, you have to remove here this confusion. Okay, you're always confused. Okay, I'm done. Okay, but you got the idea, right? Okay, guys, I'm stopping right now. Don't want to talk more than this. Okay, so bye. Thank you.